In this course, we are going to create an inventory management system with .NET 6. And the technologies that we are going to use to create the application are Blazor Server, Entity Framework Core, SQL Server, and ASP.NET Core Identity to secure the application. You will need to know a little bit C# and a little bit SQL Server before you can take this course. But the rest of the technologies will be covered in this course while I'm creating the application. So this course is focused on practice and creating the project. There won't be a whole section of concepts and theories. You are going to learn all of these concepts while you're creating the application. So if you have learned all these technologies before, but you need a project for you to practice, then this is a very good course for you. If you haven't learned Blazor, Entity Framework Core, or ASP.NET Core Identity, don't worry about it. All these concepts, like I said before, will be covered in this course while you're creating the application with me. So let's take a look at the application that we are going to create. This is the inventory management system. We are going to manage inventories, manage products, purchase inventories, produce products, and selling products. And we are going to create some reports. We also cover the functionality of signing into the application. For example, if I sign in as a inventory manager, I'm able to access inventories and products. We can add inventory. We can edit inventory. For example, if I change the quantity to 10, then it's going to be updated. We can do search and the same thing to products. But if I try to go to purchase or produce or sell products, I don't have the permission, right? For the reports, everybody has the permission to run reports. Now, if I sign in as a salesperson, I'm not able to manage inventories anymore, but I'm able to sell products. I can give it a sales order number. I can select a product to sell, specify the quantity that I want to sell, and the price. And then I could click on the sell button. Now the product is sold. And if we go to the reports, we can see that today, which is August 6th, I have sold 1 car. So you can see that the quantity before is 5 and quantity after is 4. Last but not least, you can click on this print button to print the report to any printer. So in this case, let's print to PDF. And then you can see the PDF in the folder. Let's open it up and it looks pretty good. Therefore, as you can see, we have a lot of functionalities to cover. Without further ado, let's jump into the lessons and get started. In this course, we are going to learn ASP.NET Core Blazor in .NET 6 while we are creating a inventory management system. In this video, we're going to create our project and then we're going to talk about the Blazor project structure. So I'm using Visual Studio 2022, which is the latest version as of today, February 9th, 2022. And I'm going to create a new project. I'm going to come here and search Blazor. And the first one is the WebAssembly. We are going to use Blazor Server for this course. The solution name, I'm going to name it IMS, which stands for Inventory Management System. And this project name, I'm going to call it ims.webapp. So it's clear that the web application is for the inventory management system, because later we're going to use the clean architecture, which will need a few class library projects. So we have to name them properly so that immediately we know the purpose of the project in the solution. So I'm going to click on the next button and then we see the framework. So currently .NET 6 is the long-term support, the latest version. So I'm going to select this .NET 6 long-term support version. We are not going to select authentication at this moment. We're going to add authentication later, so that we know the steps of adding authentication into an existing project. I'm going to click on the Create button. All right, so now we have our web application created. You can see that we have this program.cs file, which if you have played with console application, you must have seen the program.cs file. So let's talk about what is a web application, right? So a web application is an application that stays in the server. And then when the front-end browser sends a request to the backend server, the web application is supposed to process the request and then return back a response. So this is a HTTP request, and this is a HTTP response that contains all of the HTML. How does the server process the HTTP request? It needs an application that is constantly running to listen to a certain port. And then when the request comes into the port, the application will then pick up the request and process it and return the HTTP response back to the browser. So then what is the application that is listening? In ASP.NET Core Blazor, within the development environment, this application that listens to port and waiting for the request to come in is a console application. That's why you see this program.cs. So let's run it and I'll show you what it is. Okay, you see this console window? It says that it's the ams.webapp.exe. So this is the application that is listening right over here on the server. So I better call it web server. So the application itself is this console application, at least in our development environment. It is this console application that is running, right? And it is listening to the ports. Now, if you are confused that this doesn't look like a console application, I can show you that currently when you create a console application, it won't look like this. This is a simplified version without the main method. So I'm going to open up another Visual Studio instance, and I am going to create a new project, and let's just select this console application. And if I select .NET 6, click on create, you can see that this program.cs, there's no main method here anymore, right? So basically it just runs like a Python application that runs from the first line of code. So if we run it, you can see the console comes up. You can see the hello world is printed. So this is a console application. Therefore, indeed, this web application is actually a console application. So now let's look at the structure and the loading sequence of the Blazor application here. So once the lines of code in this program.cs is finished, the application here, see this application is a web application, right? It's a web application class, and then has a run method. Basically, this run method makes the application start as a service and listen to the ports. And once the first HTTP request comes in, the host.cs HTML page will be the page that it hits, no matter which URL you're asking from the HTTP request. What you can see from here is that if it references an application component here, which is the root component, and this application is the app component here, right? So this is basically the root component of Blazor, right? Because Blazor application is a single page application. Whether it's Blazor WebAssembly or Blazor server, it's a single page application. So everything is based on component. Even this root component, it's a component. After the root component is loaded, if the routing is found, right, the URL is found, then it will load the main layout. So the main layout is under the shared folder, right? So it goes to the main layout. So basically this is the master page. If you're familiar with web forms like 10 years ago, this is the master page that controls the layout of your entire application. And most important thing here is this body placeholder. This body placeholder is the placeholder for all of your main contents, right, that comes from your page components. We're going to talk about the different type of components. But if you consider a traditional web application that has a page, right, And then it also has a layout file, which controls the layout of the entire application. This main layout component is the layout file. And this body placeholder is the placeholder for the pages, right? Now, in Blazor application, we don't have an actual page, but we do have a page component that acts like a page. So this is the loading sequence. And let's summarize. The loading sequence starts from the program.cs, then the underscore host will act like a index.html file, and then it loads the app component, which is a root component, and if the root is found, then it will load the main layout, which is the master layout file. Then all of the page component will be loaded into the place where this body placeholder is, right? You can see that we have the index page, which corresponds to the root URL. And we have the counter page that corresponds to the /counter URL, right? And we have other, like the fetch data, which corresponds to this component. And if we run the application, you can see that this part, right, the left side bar and the top bar comes from the main layout. Whereas this part, the white part in the middle, is the body placeholder. So right now I'm on the index page, which corresponds to the root URL. If I go to /counter, right, /counter here, then you can see that this body placeholder is switching to a different component. Whereas if we go to fetch data, now you can see this part also switch to a different component. So this is the project structure as well as the loading sequence of a Blazor application. In this video, we are going to look at how Blazor works by running the project and seeing how it runs. But first, let's see how a traditional web application runs, right? So this is a traditional web application that we showed yesterday, right? We have a browser. And for a traditional web application, whenever there is any request from the user, the request will be sent to the server. And then the server processes the request and then return the HTTP response. And then the user would make another request, like clicking a button. Then another HTTP request will go to the server and the response will come back. Basically, for any actions that is taken by the user, there will be a browser to server round trip, right? Going into the server, going back toward the browser. There's always a round trip. So let's see how our Blazor application runs in this case. So this is the application that we're running. And let's turn on the developer tool by pressing the F12 button. So I am going to go to the network tab. I'm going to click on the refresh button, which triggers a round trip. And you will see that. All right. So you can see that the request is going back to the server, which in this case is localhost, right? And then coming back, we also load the blazor.server.js JavaScript file from the server to the browser, right? So there is this round trip for sure. Now, if I go to the counter page, right? So let's clear this network tab here. I'm going to click on the counter button here. You can see that there's no traffic anymore, right? There isn't any traffic. And even if I click on the clip me button, you can see there's no traffic going back. But if I do this all over again, I click on the refresh button, right, you can see that everything is loaded again. Now, if we go to click on this Blazor _Blazor ? And go to this message type, you can see that there's some binary messages going on here. Okay, what are they? Okay, so I'm gonna clear all, and then I'm gonna start clicking this clip me button. You see, every time I clicked on this button, there's going to be messages going back and forth. You can see there's green messages and there's red messages. One is the message going to the server. The other is the message coming back to the server. All right, so I'm going to clear it and then click on the button again, right? You can see there's messages going back and forth. But there's no new files loaded anymore, right? We already saw that if I clear it, I click on the button, you don't see that anymore, right? So what is on earth going on here? So let's go back to our diagram here. So how Blazor works is completely different from a traditional web application like this. So we have this browser here, and we have the server over here on the right-hand side. The first time user type in the URL in the browser or click on the refresh button, there's definitely is a request, HTTP request, going to the server, which you have seen in the network tab that I show you in the developer tool, right? So there is this round trip that happens for the first request. And afterwards, what is happening for Blazor server? So I have to clarify this. This is how Blazor server works, okay? Because we have two hosting model. One is Blazor server, the other is Blazor WebAssembly. For Blazor server, after the first request, the blazor.server.js is downloaded into the browser, which you have seen, right? So if I refresh the browser, you can see that this blazor.server.js is downloaded. This blazor.server.js file is very, very important. It helps the browser to set up a signal R channel, which connects the browser to the server. So this is signal R channel, which is a dedicated WebSocket channel, usually used in communication applications. Signal R channel is this channel here that you saw in the developer tool, right? And the messages here you see are the messages being sent back and forth through the signal R channel. That makes the communication between the browser and the server near real time. So the performance is really, really good. Right? So once the blazor.server.js JavaScript file set up the signal R channel, right, any other actions that is taken by the user in the web page, let's use this rectangle to reflect the page itself, right? Basically the DOM. Any other actions the user takes in the page will trigger an action in the blazor.server.js, which in turn will send a message through the signal channel to the server. The server then processes the request right here. And how does it process your request? It's your own code, right? Your own logic here. And then the message, another binary message sends back. The Blazor server.js file will process that message and display the information on the page accordingly. So now, what is the information that is sent back? Is it the HTML or is it something else? That will make us go a little bit deeper into how Blazor server works over here in your code, right? So Blazor server keeps a component tree on the server side. And whenever there's a message goes back to the server, it will produce another component tree. So imagine this is the old component tree, and this is the new component tree. The next Blazor framework will compare these two trees and then sees the difference, right? For example, in this component, after a user clicks on a button, another component is loaded within it. Then it will compare these two component trees, the old one and the new one. It will see that this is a new component that needs to be displayed in the DOM, right, in the page. Then it will only send this part of the HTML, including data, through the signal R channel, right? It's as a binary data, so its performance is pretty excellent. And the information is kept minimal because it only sends the difference to the blazor.server.js, and then it helps to push that information to the DOM and display that information properly on the page. So that's how Blazor server works. For Blazor WebAssembly, it works a lot differently. Basically, Blazor WebAssembly is almost the same as other single-page application frameworks. It downloads all of the code into your browser, and then in order to get more information from the server, you need to call a web API. But everything is processed in the browser through the WebAssembly runtime, which is out of the scope of this course. But this is how Blazor Server works. In this video, let's talk about what is an inventory management system. So inventory management system is basically, you have some inventories and you want to manage them. So let's take this rectangle to represent a warehouse, right? Where you store, or at least temporarily store your inventory. And if this rectangle is the inventories, right? And typically, at least in the inventory management system web application that we are going to create, we have a warehouse that not only store the raw materials, right, the inventories, but also we make products out of the inventory, right? So when we use the inventory to make things, the end results are the products, right? So basically from here to here, we have an action of produce, right? So when we produce, the number of inventories decrease and number of products increase. There's another action here, which is when we sell products to the outside of the warehouse, the number of products also decrease, and that action is selling. Now we have producing, we have selling, and when we don't have enough inventories, what's going to happen, of course, is we need a shipment from outside to inside. This we will call it purchase. In our inventory management system, we're not directly going to deal with shipping and receiving, but would deal with purchase, right? Like purchase orders. So when we have a purchase order and when we fulfill the purchase order, right, we'll receive inventories, right? And when we purchase, the inventory increases. When we produce, the inventory decreases, but the products increases. And then when we sell, the number of product decreases. So this is the inventory management system, right? On top of all of this, we're going to have to have a reporting module, right, to report the number of inventories, the number of products, and how they change across different days by different actions, whether it's purchase or produce and sell. We want to see the number of inventories before a particular action, like purchase, right? We want to see the number of inventories after that particular action, so that we can always track on what day and what have happened to the inventories or products. As the management of your business, you want to be able to look into all these factors in order to properly manage your warehousing or your product producing or inventory purchasing. So this is the inventory management system that we are going to create with ASP.NET Core Blazor. In this video, we're going to talk about architecture, because very soon we're going to start coding, but what kind of architecture are we going to use in order to finish this pretty big system? Traditionally, we have the layered system, which, we have a database, right? And then we have our data access layer, depends on the database. Nowadays, we often call the database access layer repository. And then on top of that, we have business logic layer. And finally, we have our user interface layer. But this is not going to be the architecture that we are going to use in this course. We are going to use clean architecture. So what is clean architecture? So if you do a Google search, very soon you will find this blog post from cleancoder.com. So this is from Robert Martin. This puts everything in an onion structure, right? So you can see that in the middle, it's the entities. And then you have use cases and everything else, right? The entities are basically the models, right? The classes. that will be used in all kinds of different layers, right? It's very important to notice that the dependencies are going inside, right? So the outer rings are dependent on the inner rings, not the other way around. So let's focus on the core. In my opinion, the core are both the entities as well as the use cases. So the entities can contain the model classes as well as some logic that is not application dependent, right? So it's basically a lot of validations. You're creating application that stores personal information, and there's this that state and the birth state. So a very, very basic validation is that the birth state has to be earlier than the death state, right? So those kind of logic is the core. It's not dependent on applications, right? Even when you use pen and paper, you are still going to have those validations, the same logic. So those logic will go into the entities layer along with those model classes. Whereas the use cases layer, which is one layer above that, that one stores the application logics. The logic in the use cases layer is for the application. So without the application, those logic won't exist. Whereas within the entity, those business logic are those logic that doesn't depend on any applications. Without existence of applications, you still have those logic, because even when you run your business with pen and paper, you still have those logic, right? And another thing, we can see that we have user interface on the outside, which is very, very understandable, because UI is always dependent on use cases and entities, right? But you have this database and you have devices, right? So the database and devices, those are I/O devices. Why they are also outside instead of inside, right? So if we look at this typical scenario, the database is the bottom layer, means everything on top of that is dependent on database. Whereas in clean architecture, the database and devices are on the outside, right? So to understand this part, imagine you are creating Visual Studio, but you know that Visual Studio can have plugins, right? So let's imagine this is a plugin, right? And this is a plugin, and this is another plugin. So these plugins can be plugged into Visual Studio to extend Visual Studio's functionalities. You always create Visual Studio first, and then plugins can be developed by someone else, not Microsoft, someone else, right? Because Visual Studio is developed by Microsoft, but anybody can create Visual Studio plugins. So how does that work? Well, that's very simple, because Visual Studios, when it's created, you need to create the interfaces so that when other people create plugins, they can just look at the interfaces. As long as they abide by the interfaces, then they can talk to Visual Studio, right? Visual Studio then can use them because of the compliance to the interface that's already created by Visual Studio team. So the key here is that the plugin interface is created ahead of the time. Same thing here. When you create use cases and when you want to talk to the database to pull data into your use case to use, your use case layer shouldn't be dependent on the databases or a file or API, for example. They should be the other way around, which means your use case layer, right? Use cases layer should contain a bunch of interfaces, right? And then your use case will talk to the interface, and then you will create the database layer as plugins to plug into your use case layer. That's why you have your database or devices layer on the very outer ring. So the keys to the clean architecture are not those technologies or the tools, but these two things: use case driven and plugin based, right? So you always look at the use cases first. You create the use cases first. You drive your software development by use cases. Of course, you can have your unit tests on top of use cases to do test-driven development, but even when you do TDD, you still think about use cases and what use cases you want to test, and then you can start with your testing layer and go into the use cases layer, go into entities, create your database interfaces within this use cases, and then you can plug in your database repositories into your use cases, right? So the first key here is use case driven, and the second key here is plugin based, right? Use case driven is referring to the core, and the plugin based is referring to any IO devices, any IO operations will be in the DB layer that is outside of everything, right? It's the outer ring. So that's clean architecture. And if you don't understand, because this is very theoretical, in the rest of our course, you will have a lot of opportunity to see how it actually goes when we write the code. And of course, I have a separate course for clean architecture. You can look in my website, frankliucs.com, and find the clean architecture course, which is on Udemy. Nullable reference type is enforced in .NET 6. So in this video, let's talk about nullable reference type and see how we should use it properly. I have Visual Studio open. Let's create a new project, and we are going to create a console application. We're going to select .NET 6, hitting on the Create button. Now we can see our console application. And before we code anything, let's go to this project file. And you can see that we have this nullable, which is enabled. Let's actually disable this for now. And so this kind of revert back to .NET 5. And let's program something and see without enabling nullable what's going to happen. So let's actually create a class first. Let's create a person class, and we are going to have a property that is called name with string type. Let's also create a function which is going to print the length of the name. And this is going to be a void, and let's call it print name length. It's a very simple method here. I'm going to do console.writeLine, and I'm going to say name dot, okay? And at the beginning, of course, we can instantiate the person class, and now directly call the method, okay? If we do this, you see Visual Studio doesn't give us any warnings whatsoever, and if we run it, you see that we have an unhandled exception here, null reference. Why is that? Obviously, we didn't initialize the name property. Therefore, the initial value is null. And we're trying to get the length of name, which is null. Of course, you're going to throw a null ref exception. So let's put back the nullable reference enforcement in the project. And then let's go to program.cs. Now you can see the difference is that it gives us a warning here. And what is this warning? It says non-nullable property name must contain a non-null value. It basically forces us to assign an initial value when the class is instantiated. So now when we run this, of course, it's not going to give us any problem. It's going to tell us the length of the name is 0 because it's an empty string, right? So let's try something else. Let's actually explicitly assign null to the name. And when I do that, immediately you can see that we have a warning here. And it tells us that we cannot assign a null literal to a non-nullable reference type, right? So this is a non-nullable reference type. So basically you cannot assign a null value to it, and it gives you a warning. You can actually change the Visual Studio setting so that this becomes an error. And you would have to resolve this before you run the application. Right? If you want to, you can configure it. So what this nullable reference actually does is that it analyzes your code at development time. It gives you warnings, right? So it kind of helps you to avoid null reference problems. But never ever think that you don't have to do null checks anymore. Everything is good. You won't face null reference problems. Actually, you have to remember, this is only help you at development time. Runtime null reference problems is still happening. It's still happening, right? So for example, right now, if you assign a null value, you are still allowed to run the program right? And you're going to have an unhandled exception, a null reference exception, the same exception that we faced before. The only difference now you can see is this warning, right? Like I said, it does a whole bunch of null analysis and provide warnings to developers at development time. So you have a chance to fix those problems. But you should not, and I emphasize that you should not forget about doing null checks, right? For example, here, you should still, like before, you should still say this, if name is not now, then we're going to print it, right? Otherwise, we can print some kind of error messages, which I'm not going to do in this video. So in this case, even when this value is now, your program is going to be okay. But you may ask that we are explicitly assigning a null value to a non-null reference type. This wouldn't happen. But you never know, because for example, if you call a web API that is written by someone else, and that program is from a class library that is written in the past, right? You never know whether it's going to return a null value or not. So do not change your habit of doing null checks, right? When it makes sense. This null reference type only provides some warnings, good for you to fix your potential null reference problems, but always double check. So that's what I want to say about this null reference type in .NET 6. In this video, we are going to start writing our first use case, which is related to the inventories. So this is the final application that we are going to create. This is the application that I created for one of my videos on my YouTube channel. I'm showing you this application just so that we can kind of gather some requirements. You can consider this application as a mockup. Let's say this mockup on the paper. But for the purpose of convenience, I'm just showing you the final application. By looking at the final application, we can see what kind of use cases are involved in these screens. Let's go to our first screen and see how we can write a use case. So I'm hitting on the inventory menu, and I'm seeing this inventory list, which shows all of the inventories in the system. Now, when you have a lot of inventories, this may not be a good idea. You may need paging, right? But for now, we are showing all of the inventories, right? Another thing we notice is that if we start typing, right, we can see that we can filter based on things. Or if we leave the text box empty, click on the view button, it's gonna again give us all of the inventories. And of course, we can also click on the view button to trigger the search behavior. So this is the first use case. So if we were to write a kind of a more official use case, then how do we write it? And that's what we're gonna do in this video. So I'm just going to use Notepad to work on this. You can start with a user story sentence, right? So you can say, as a user, I can view inventories as well as search inventories. Better say, I can view all the inventories as well as search certain inventories by names so that I can manage them, right? So this is basically a very simple statement as a user story. But to provide more detailed information, we're gonna continue writing as a use case. So for use case, we need preconditions, post conditions, and we need detailed steps. Right, so this is a main scenario where the precondition is the user is on the inventories page, and the post condition is the user sees the inventories that meet the search condition. The detail steps is, the first step is the user enters few letters in the search box, and the user clicks on the view button. Right, so after this, then it will reach the post condition. And then of course we can have our alternative scenario A, right? And in here we are going to have also the 3 sections, but if the precondition is the same, then we can delete them. And in here, the alternative scenario A is when the user doesn't enter anything, basically keeps the search box empty, and then click on the view button. So we have the same precondition, so we can delete this. And then the post condition is basically the user sees all the inventory, right? Inventories. And detail steps is the user makes the search box empty. The user clicks on the view button, right? And this has to be changed to 1A and 2A. So basically 1A replaces this number 1 here, and 2A replaces this number 2 here, right? And after that, we go into the post condition here, and this has to be 2A. So this 2A also replaces number 2 here. The reason why we want to do this is because if we have a lot of steps, for example, in the detail steps in the main scenario here, then if the alternative scenario does not require you to change all of the steps, in this case, it's probably not a very good example. We are changing all of the steps. Actually, the user clicks on the view button. See, the user clicks on the view button is not being changed, so we don't even need to mention this, right? So it's basically, when you write alternative scenario, you don't have to repeat all of the steps, right? You can just mention the ones that needs to be replaced, and then you just need to specify the number correctly, right? So this corresponds to A here. So 1A basically replaces this. So if we have a alternative scenario B, so the alternative scenario B is basically for the scenario where the user are not clicking on the view button, but we want the searching functionality to be activated when the user hit the enter. I know this is different from the final application that I just showed you, but this time I want to change it a little bit. So in the alternative scenario B, do we have the same precondition? The user has to be on the inventory page. Do we have the same post condition to the main scenario? Yes, we have the same post condition. So the only thing that is changed are the detail steps. So the detail steps are changed, but the first steps are not being changed. The user enters a few letters in the search box, but the second one needs to be replaced, right? So we have 2B, the user hits enter, hits the enter key, the same post condition will apply, right? The user sees the inventory that meets the search condition. All right, so this is what we are going to implement, the first use case. In the rest of the course, I'm not going to write all of this because I want to save you some time. But for this first use case, I'm writing this as a template for you. I do suggest you, if you want to follow use case driven development, or even not use case driven development, but still requires use case, I'm just having this template as example, right? You can write your use case differently, but this is how I write my use cases. If you have a QA team or QA person, they can take a look at this documentation and test accordingly. For us, because we are developers and we are in this project, at least in this course, we're doing use case driven development, right? Clean architecture. So we do need a use case documentation like this. So in this video, I just wanted to show you how to properly write a use case so that both developers and QA team can use the documentation for development as well as testing. In this video, we're going to implement this view inventories use case. But before I do that, let me just take a little bit of time to explain to you why I think it's better to start with implementing the use case layer, right? So some people said to me that this is still a layered architecture, not clean architecture. But I have to tell you that actually clean architecture is layered architecture. It's a type of layered architecture. The only special part is that it has the center, and the center is entities and then use cases. And the database is not in the center. The database is on the outside layer. Right, so that makes this clean architecture, and those two key things that I mentioned, use case driven and plugin based, those makes a layered architecture clean. So in this video, I want to explain to you why we want to start with use cases just a little bit, because business logic is the purpose of this type of business applications, right? We're writing the application to implement the business logic. That's why we want to start with the purpose and end with the purpose, right? Because creating the application is not the purpose. Using a particular technology is not the purpose. But implementing the business logic is the purpose. And also because the use cases layer implements business logic. That's why we want to start with use case. The second reason is that when we implement use cases, right, these use cases makes our developer focused on the business logic instead of user interface or database. So it's not UI centric, it's not DB centric, but use case centric. And because our use case layer is not technology dependent, therefore you can use the use case layer in any type of applications, whether it's mobile applications or desktop applications or web applications. You can use the use case layer. In some cases, like a mobile application, you may want to use web APIs to wrap around the use case layer to expose the functionality outside, right? In other applications, like Blazor server applications, you may want to skip that web API layer. Like in our project, we are going to skip the web API layer. But if you want to write a Blazor WebAssembly application, then you will have to wrap the use case layer with a web API in order to expose the functionalities outside from the use case layer. And that's what the gateways, presenters, and controllers are. And therefore, in our case, in this video, we are going to start with implementing the use cases. So we're going to start implementing this first use case, which is the view inventories, right? So we are going to go to our Visual Studio, and we are going to create another project, right? I want to have a class library that is separate from the web application for the purpose of making it independent from technologies. I don't want to put the logic inside the Blazor application because it can be used in other applications. So let's search class libraries and language C#, right? So go next. Here you can see that the structure is like this, right? So we are going to make sure the project is correct. So IMS, inventory management system dot use cases, and the framework is .NET 6, and hitting on the create button. So let's take a look at the structure, the folder structure. We want to make sure it's all correct, right? So we have the solution file here, we have web application here, which is the folder, and the project file is inside, right? And use cases also has a project file inside. So this is a perfect structure. So we're okay with that. Now, we know that we are going to have a lot of use cases, right? For this particular use case, it's view inventories. So how do we organize the use cases? We can organize them by screens, right? Because one particular screen may have many use cases. For example, the screen that I showed you for the view inventories, it not only have view inventories, but later it will have edit inventory, it will have add inventories, right? You may want to group them by screens, or you may want to group them together by a concept. So let's, in this case, just group them together by a concept, right? Well, there's many other ways to group them as long as it all makes sense. I have other courses that I group them by screens. I think it's a good way as well. So inventories. The reason why I'm not so consistent about these groupings is that I want to show that there's a flexibility, according to your style and your project. I'm gonna delete this class 1.cs, and I'm going to create a class, and I'm going to call this view inventories use case. I'm gonna change this to public because I'm going to use this class in a different project. And here, if we look at the use cases that we have written, to implement this use case, we will need to be able to supply the search conditions, which basically we're searching by name, providing a few letters of the inventory name, which I should have specified more clearly here, right? So the user enters a few letters in the search box. This part is the part of the inventory name. And then what it returns is supposed to be a list of inventories so that we can provide that list of inventories to the UI and let the UI display it. And now we can come back and continue with the use case. And first of all, I want to change the use case name to view inventories by name. I think that's what it really is, right? By name. And then we can continue with the use case. I like to name my method as execute, right? And the method will return a list of inventories, right? So I'm gonna call it execute async. I'm gonna use async way to do it. And the parameter is going to be name. And there's a default value, which is empty. Here, because I want to use async method, so I need to use task to wrap this around. And the reason why I want to use async method, I'm going to cover that later because I don't want to cover everything at the beginning, so there's just too much at the beginning to start with. I want to ease into this process a little bit. So now I don't have an inventory, right? So this is a way of doing development similar to test-driven development, where you just start writing and you correct those squiggly lines, right? Now I see a squiggly line. I know that I don't have inventory, so I need to create an inventory. So where does the inventory stand, right? It stays in the center of the center in the clean architecture rings, right? So it's in the center, which is the entities. So it should be this entities in the middle. So what I'm going to do is I'm going to create another project just so that we can have very clear separation of concerns. So I'm going to select class library, go to this, and here I'm going to call it ims.coreBusiness. So I don't want to call it entity because entity sounds more related to a database terminology. So I don't want to use a technology term. I want to use a business term. So that's why I call it core business, to refer to the center of the center in the clean architecture. So clicking on the next to create this class library, and I'm going to hit the F2 button to name this class inventory, changing the name to inventory. So what are we having inside the inventory? We don't have to consider right now because, again, similar to TDD, you want to do minimum work to get rid of the squiggly lines. So here we just need to add a reference to the core business project, and then come over here. We need to do control dot to import namespace. Now we don't see the squiggly line anymore. So what do we do here? In any use case method, we have business logic inside, right? So imagine here we're going to retrieve data from database, which contains a list of inventories. And then we need to do something with that inventory. We can do it here. But because in this particular case, we don't have anything to do once we get the inventories. So it's going to be a simple pass through. So all we need to do is to get the data. Then how do we get the data? Remember that in clean architecture, data is outside, right? So we cannot be dependent on the data layer or the repository layer. Therefore, we need to use interface as an abstraction of the data store so that our use case can work with the abstraction. And then later, we can implement this interface as a plugin to plug into this use case. Therefore, our use case is not dependent on the plugin. Our use case is dependent on this abstraction. And this is one of the key concepts of clean architecture. And I'm going to use interface before creating the interface. Though, again, this is very similar to test-driven development. You just write the test case without even having any definitions or declarations. This may feel a little bit weird, but if you bear with me, you will know what I really mean. So first of all, I will have a constructor here. And then I'm going to use this imagined interface, which I'm going to call it inventory repository. Right? I'm just imagining that I have it already. And then I'm going to do control dot. Right? And I'm going to initialize this. Now I have this inventory, and then I can use it. So like I said, this is going to be a simple pass through, and this is going to be called, let's call it get inventories by name. And we can just simply pass this through. And we're going to return, this is going to be an async method, so I'm going to add async at the end. Like I said, I'm going to explain why we need to use async a little bit later. So now we see that we need to define this inventory repository. And like I said before, the interfaces should be sitting inside use cases. Only by doing that, we can plug the I/O related codes like database or file systems from outside into our use case layer, so that we can have a core that's not dependent on any external things. That's why I'm going to come over here and create a folder, knowing that I'm going to have many interfaces for plugins. So I'm going to create a folder, and then I'm going to create an interface inside it. Right? I'm going to call it inventory repository. And the method here is enumerable inventory, control dot to import the namespace. It's called get inventories by name, and then it takes the name. Right, so this is the interface. So when we come over here, we see that there's still squiggly lines. We just need to do a control dot to import the namespace. Now everything is fine, except that this, it's complaining that it doesn't have this method in the interface. So we might have forgot the async. Yes, we forgot the async. What we have done so far is that we created the use case, and we created one of the interface that we need to use for the use case. The use case is dependent on the interface, and we have a complete core in the clean architecture. The next step is to implement the interface in data store layer as a plugin to plug into the use case. The plugin will need to implement this interface, and then we can use dependency injection to inject the plugin into the use case, which I will show you in the next video. In this video, we are going to implement this abstraction to help the use case to get inventories by name. To do that, we will need to create a plugin, because a plugin is plugged into our application, so it's replaceable. To demonstrate that, I want to create an in-memory plugin first, and then later we can replace that with another plugin that is made of Entity Framework Core. Because of that, I may have different plugins. So first of all, I need to create a folder. So I'm going to add a solution folder under the solution, and then I'm going to call it ims.plugins. And this is a logical grouping. So there isn't actually a folder created. See, you can't see the folder. So we will need to actually create this folder to correspond to that logical folder. I give it the same name as this logical folder here. And then under here, I'm going to create another project, and it's going to be a class library as well. And the location is the plugin folder. Project name, I'm just going to call it ims.plugins.inMemory. Right? So later I can create another project and place it under the same folder, but I call it ims.plugins.efcore, right? Stands for Entity Framework Core. But for now, let's implement this in-memory plugin. Another benefit of creating an in-memory plugin is that you can use it for testing to facilitate your test cases so that you can have a fixed set of data to test with, so that your data does not change, right? Because if you use database, the data in the database will change over the time, so which will make your test cases fail. But if you use an in-memory database that have a fixed set of data to start with, so you always will have the same data to work with. So in this in-memory plugin here, I'm going to have a inventory repository, right? And this will implement the inventory repository interface in the use case layer. So that's why I need to add a dependency here, right? A project dependency to the use cases layer. So this reflects the clean architecture where you saw that the data store layer, which is the outside ring, is dependent on the use case layer as opposed to the other way around. And then I'm going to do control dot to import the namespace and do another control dot to implement the interface. Right now I only have this one method here. So then here I'm going to hard code some data here for a list of existing inventories. Right, so I'm going to call it inventories. The inventories will be populated with some data. So now it's the time to give our inventory some field in order to initialize the inventory list with a list of inventories. So then to do that, we can go to our core business layer. We can add some property in here. So of course, inventory class will have an inventory ID, and then we will have a inventory name. Do we ever allow our inventory name to be null? No. Because of that, I'm not going to put a question mark here, right? I'm going to initialize it with empty string. So this is something new in .NET 6, which is called nullable reference type. We initialize it with an empty string so that we can avoid the possibility of having null reference exceptions. Now we have the quantity property as well as the price of the inventory, basically the cost, right? And then we can go back and we can initialize something. So let's say we are producing bicycles, right? So let's call it bike. And for bike, what kind of parts do we have? We have bike seats, and let's say we have 10 already, and the price is, let's say $2 as a cost, right? And then we will have bike body. And we also have 10. And bike body is, let's say, $15. And we also have bike wheels. Let's say we have 20. And then each cost $8. We will also have some bike pedals. We also have 20. And let's say each cost $1. Now we are going to implement this method. And first, we'll need to check whether the name that is passed in is null or white space. If it's null or white space, we are going to return everything. And here, because we're using a task, and also because we're using in memory, so we can use task dot from result. We can just make it async, and then we do a wait. And if the name is not empty or white space, then we really need to filter the list that we already have in here. And for that, we can use the inventories .where, and we can use the inventory name that contains the name, and we are going to use the ordinal ignore case parameter here. And this where method returns I enumerable, right? And that's what we want. So we implemented this abstraction. Therefore, this inventory repository class can be used as a plugin. Then how do we plug this into our use case? What we need to do here is that we need to register this interface and its implementation in the service collection in our Blazor application, which is this web application here. So for that, we can go to our program.cs. All of these are basically registering the services that are needed in all of these pipeline middlewares. We will do our dependency injection here, right? You can see that we have this services collection here, and we will need to add singleton. Later, I will explain what add singleton is, but for now, we are just adding a mapping between the interface and the actual implementation. And then I'm going to do control dot to import the namespace here. And of course, we'll also need to add a project reference here to the in-memory plugin. And after that, control dot to import the namespace. Now, inside our ASP.NET Core Blazor application, we have this mapping. Therefore, whenever our use case is required by our Blazor application, ASP.NET Core will see that the use case requires this interface. Then it will go into the service collection to see whether there is any implementation for this interface. In this case, it sees that we did provide this inventory repository concrete class. Therefore, it will instantiate an instance of this concrete class and provide it to this constructor of the use case. And then in the constructor, the variable inventory repository will receive instance of the concrete implementation of the object. So this completes the process of plugging. And in the next video, we are going to see how this use case is used in our Blazor application. In this video, we are going to use this use case in our Blazor application. And to do that, we are also going to use dependency injection. For that, first of all, we will need to create an interface for this use case. So I'm going to do a control dot on here, and I'm going to select the first one, extract interface, and click on OK. So automatically Visual Studio does the work for me. So it created this interface right here. Now for file organization purpose, I'm going to create a folder so that I can put all of the interfaces inside this folder, because I know that under inventories folder, I'm going to have other use cases. Now that I have the interface for the use case, I can again go to the program.cs file and I can do a dependency injection. And this time, instead of using singleton, I'm going to use transit. As I said, later I'm going to have a lecture that talks about dependency injection by itself. So again, I'm going to have a mapping between the abstraction and the concrete implementation. I'm going to do a control dot so that I can import the namespace. Now that I have added this mapping to our service collection, I can require the use case in the Blazor components. Before I go ahead and create different components, we can use the index page. And I'm going to change the title to test page. So I'm going to use this page to display some of the existing inventories that we hard-coded in the in-memory data store. In order to use the use case, I'm going to come over here and do a @sign. So this is a page directive that tells the framework that I am injecting the use case in here. I'm injecting an instance of the concrete implementation of this abstraction, right? The abstraction that are represented by this interface. And I call it view inventories by name use case. And then I can come over here and add a code block. So this is where the logic goes in a Razor component, which is the Blazor component. Microsoft calls all of the Blazor component Razor component. So Blazor component or Razor component, they refer to the same thing, which is this type of component that we are coding with. So within the code block, that's all of the logic goes. First of all, we will need a list of inventory. This is a variable that will store the inventories that we have. And again, in .NET 6, you will have this green squiggly line that is warning you that this is a non-nullable reference type. So you have to assign something to it to initialize it. Otherwise, it's going to warn you, right? So by doing this, we are avoiding having null reference exception. Now, for single page applications, all of the components has state, right? So this is not stateless. This is stateful. That's why we are going to have a sequence of different events hooks that are triggered through the life cycles of a component. One of the first ones that are triggered is called onInitialize. And that's where we are going to use our use case to retrieve the inventories. So I'm going to do override, and then you can see that we have this onInitialize async. Because our first use case is using the async method, that's why I'm overriding the async version of the onInitialize event. Then over here, I can use this variable here, and then I can do dot execute async. Right, so if I don't pass in anything for the name, then it will return all of the 4 existing inventories for me. Okay, I can make this async, and then I can assign the result to the inventories method by putting a await here. Now it's still warning me because is a returning IEnumerable, whereas we are having a list here. So I'm gonna do a toList, and that should get rid of the red squiggly line here. Now it's gone. Okay, so we have the inventories assigned to the inventories variable. Then we can use the inventories variable inside our HTML section, right? So all of these above the code block is inside our HTML section, right? And everything below is our code block. When we want to represent the data in any way, we can write HTML in here. What we can do is we can add an unordered list, and then we can make each inventory name displayed in the list item. How do we do that, right? So we can use a loop, which we can utilize something that is called Razor syntax, which is a mix between C# and HTML. So if you're familiar with C# and if you want to manipulate the look and feel, then you can use the Razor syntax as opposed to JavaScript. So we can do add for each. The @ sign is telling the compiler that as a developer, I'm writing C# as opposed to HTML. Right, so I can write regular C# for each inventory in the inventory list, and with the curly braces, I can put the list item in there. One thing here, the curly braces, you will have to write it. Just because there's only one line underneath the for each, it doesn't mean that you can omit the curly braces. Without the curly braces, it will not work. Basically, for any places that requires curly braces, for example, for each, for, or if statement, you won't need curly braces. Right, for here, we have a list item. So we will need to display the inventory name. One other thing you will have to know is that once you have the @ sign, it tells the compiler that you are writing C#. Right? Once the compiler encounters a HTML element, then it breaks the flow of C#. So here you cannot just say I and V to represent the inventory variable here. It will consider this as a plain text. So because the flow of C# is broken, in order to still write C#, you have to also add a @ sign here. Now the compiler considers that this I and V as a variable that is defined over here. I can just put inventory name here. Now we should see a list of all of the inventories under here. So in order to make it look better, I added line break here. And now we can give it a test. So I'm going to click on Start Without Debugging. And you can see we have all of our 4 inventories displayed on the index page. So what if we only search, for example, one of them? Right? We can do some testing here, make sure everything works fine. Right? So this purple squiggly line is basically saying I updated the code, so I will have to rebuild it. So I click on this, it will say rebuild and apply changes. Now the code is reflected and I can only see bike body. And what if I put something that doesn't exist, for example, Apple, right? And again, you can see that it's not crashing, it's just not displaying anything, which is expected. Although Apple doesn't exist, IEnumerable inventory here is not null. So the toList will not throw exception. It's just an empty list. So this is what I wanted to show you in this video regarding how to use our use case inside our Blazor component. I also introduced the razor syntax to you a little bit. We will continue in the next video. If you have any questions, don't hesitate to ask in the Q&A area. If not, I'll see you in the next video. In this video, we are going to talk about dependency injection. In the past 2 videos, you have seen that we have been using dependency injection. And when we are using dependency injection, one of the first things you see here is that instead of instantiating an instance of the repository directly inside the class, right, inside the method here, we are feeding the instance of the inventory repository from outside. And if we go to the component, we can see that we didn't use the new keyword to create an instance of the use case. Instead, we're also using dependency injection to feed the instance of this class from outside. So what is really dependency injection? I have explained this concept in different courses using different ways. In this course, I'm going to use again another way to explain dependency injection. Right, so for example, we have our use case here, and this use case class needs to use the repository class. Typically, without dependency injection, you would create this repository class instance right inside the use case. By doing that, the use case class is responsible for controlling the lifespan of repository, which creates a closely coupled relationship. The use case class needs to know the definition of the repository class. As soon as the repository class gets changed, the use case class will need to change accordingly, or at least gets recompiled in order to keep up with the change of the repository. Basically, the higher class will need to be responsible for a lot of things for the lower level class. And when this use case is used within the Razor component without dependency injection, the same thing would happen. And in that case, our Razor component will also have to be responsible for instantiating the use case class and be responsible for managing the lifespan of the use case class, which again creates a closely coupled relationship between the Razor component and the use case. So you can see that without dependency injection, you have a chain of classes all chained together and knows each other one by one by one. And all of them are closely coupled. So when we have dependency injection, what actually happens is that we have all of these classes registered within the framework. So we have our framework right here. And then instead of having our use case here inside the Razor component, our use case is registered in our framework. Of course, our repository is also registered within the framework. Now, when our Razor component is initialized by the framework sees that the Razor component requires an instance of the use case. And then it goes into its service collections and it sees that the use case is registered in the service collection. So the framework is then responsible for creating an instance of this use case class and then feed that instance of the use case class to the Razor component. While it's creating the instance of the use case class, it noticed that the use case class also requires an instance of the repository class. And because it's also noticed that the repository class is as well is registered with the framework as well. So it is able to create an instance of the repository class and feed that class to the use case. Therefore, it completes the creation of this chain of dependencies and then inject the use case into the Razor component. And Razor component is then able to use the instance of that use case class to complete the logic, the business logic that the Razor components requires. And let's again look at the code. So we have our Razor component, which is this page component that represents the index page. The Razor component uses the inject directive to tell this particular component requires an instance of this view inventories by name use case abstraction. And then we can see that in our program.cs, where we do our dependency injection, we have a map between the abstraction and the implementation. So when the component is initialized, the framework will then provide an instance of this view inventories by name use case class. And then if we go to the implementation of this class, you can see that the use case also requires an instance of the inventory repository abstraction. And then if we go to the program.cs, we can see that we registered a mapping between the abstraction and the concrete implementation. So you see that the sequence of dependency injection is from the Razor component to the use case and then to the plugin that is plugged into the use case. In this case, it's our in-memory plugin right here. So this is dependency injection. And this dependency injection enables our clean architecture. It enables us to be able to create a repository, right? A data store layer as a plugin that is plugged into the core of our clean architecture, which includes the use case as well as the entities, right? The core business layer. But what are these add singletons and add transient methods? These are for lifetime management. Remember that when we register our use case class and repository classes into our framework, we offload the lifetime management from the higher level class or component to the lower level class, and we allow our framework to provide us with an instance of the class. And when the framework does that, the framework needs to know when the object of the class needs to be disposed. And that's when we need to use these methods to indicate, to tell the framework how long these instances need to live. So let's first look at transient. As the name indicates, whenever we require an instance of the class, it will create us with the instance of the class. So it's very simple. The framework itself does not store the instance of the class anywhere. Whereas comparing that to the singleton, when our application requires an instance of this concrete implementation, it will not only just create an instance and provide that instance to our application, but also store that instance in the application. And that instance will stay there for as long as the application is running. So when multiple users require an instance of this abstraction, the same instance will be provided to each one of those users, right? And it's the same copy, not different copies. So comparing that with the transient, when different users are asking for a copy of this abstraction, those users will get their own copy. And there's actually another lifetime management method, which is called add scoped. In Blazor server, we have this scoped concept. We go to this diagram, you can see that we have this signal R channel. When we say an object of a class that is injected into our framework has a scoped lifetime, it really means that the instance of that class, right? The instance of this, whatever we are creating, for example, if we are creating this as a scoped, it just means that this instance will be not only created and provided to the application to be used, but also stored in the application. But it will only be stored for as long as the lifetime of the signal R channel. For example, if we use the refresh button in the browser, it will disconnect the signal R channel and reconnect the signal R channel. So when it disconnects the signal R channel, that instance of the object will be also disposed at the same time. But once the instance is created and stored along with the signal R channel, as long as the signal R channel is not interrupted, is not recreated or disconnected, when you require an instance of this object, it will be retrieved and reused, right? It will not recreate another instance of the abstraction like the add transient method. These are the three different types of lifetime management for dependency injection in Blazor server. In Blazor WebAssembly, the scoped and singleton are the same thing. They are the same thing because there's no signal R channel, there's nothing to do with the server, so you can't have a singleton concept, right? Each browser has its own copy of the code and its own copy of the framework. So that means the scoped and the singleton lifetime management are the same for Blazor WebAssembly. In this video, we are going to talk about page component, and then we can use the page component concept to create a inventory list page. As you know, single page applications are based upon the concept of components. There isn't actually a page. Therefore, in order to create a page, we actually have to use component. The pages folder here, all of them are components. And later, when I show you how to create reusable components, you will see that they are exactly the same. Now, we want to create an inventory list page. So we can go to the page folder and we can add a Razor component. And not Razor page, they're completely different. But a Razor component is a Blazor component. You can choose to remove the component, right, so that it indicates that this actually behaves like a page. Or you can leave the component there. It's up to you, right? So if you come from Angular or React, you may want to keep the component there, but otherwise, you can remove the component. In this course, if the component is a page component, I'm going to remove this component. And I'm going to call it inventory list. Actually, before we do that, I want to create a folder that contains all of the inventory pages, because I know that there won't be just one inventory page. I'm going to call it Inventories. And then here, I'm going to create a Razor component inside that folder. And first of all, we're going to remove the component word. And I'm going to call it Inventory List. We have this title here. I can keep the title. But in order for Blazor application to be able to navigate to this component as a page, we will need to add something that is called page directive. And the page directive will always start with a slash. But you need to make sure that there are no other component that uses the same. Although one component can have multiple page directive that points to different paths. So if I use this, then there's going to be a problem because in the index page component, you already have this path here, right? You cannot duplicate the path. So I'm going to call it Inventories. With that, we already created our inventory list page. And if I run it, and if I go to /inventories, you can see that inventory list is loaded, right? So this is the inventory list component that is showing in the middle of the screen. Now I can add an item in this navigation menu here. In order to do that, we can go to the shared folder and there is a nav menu. Because we are not going to use the counter, we're not going to use fetch data, so I'm just going to remove the last one, and then I'm going to change this one to inventories. And I'm going to change the wording here to inventories. Notice that this inventories is the path that corresponds to the inventory list page directive here, right? So this inventories must be the same as the path here, except that we don't need to provide this slash here. So after I make these changes in the nav menu component here and click on this hot reload button, I can then go back and see that I'm currently on the inventories page. And if I click on home, I'm going back to the index page. Clicking back to the inventories, then this inventory list component is reinitialized. We take a look at the network tab. When I go back to home and navigate back to inventories page again, I don't see there's any network traffic. How does the routing actually works? The routing functionality is provided to us from the router component. So if we go to app component, which is the root component, we can see that we have this router component. This router component is provided to us from the framework. So basically this is what Microsoft created. We are just using it. And then this first parameter here is basically telling the router component which assembly it needs to look for the corresponding page components. If we have components that are created in other projects, right, in the class libraries, then there's another parameter we can add, which is additional assemblies, right? So you can add additional assemblies that contains components under the router component. Then the router component will be able to find those other components that reside in other projects. So because we have the router component, when we are navigating with the nav link component, right? So I'm just highlighting that this is actually a component as well, which is from Microsoft as well. When we're using the nav link component and points out where we want to go by specifying the path, the router component that is specified within the root component is able to look for where that component is by going through the list of assemblies. Once it locates the component, then it will initialize the component and display it in the correct position that is specified by the main layout component that I talked about before, right here, inside the body placeholder. In this video, we are going to talk about components best practice in single-page applications like Blazor in terms of breaking down a page into different components. Well, let's go back to the diagram here, right? So for a traditional web application, we know that a browser will always send a HTTP request to the server and come back with HTTP response. Well, mostly, right? Unless we use JavaScript. But mostly we go back to the server. So it's a stateless programming model. Whereas in Blazor or any other single-page applications, because we have everything loaded to the browser or going through the SignalR channel, the browser actually maintains the states of the components. So here in single-page applications, everything is stateful. So because everything is stateful, when a page contains a lot of functionalities, right? Like this page, well, it doesn't contain a lot of functionalities, but I guarantee you, if you put everything together in one single page component, it will look so messy and the maintainability is going to go very low. So that's why I need to have a video to talk about this. What is the best practice in terms of breaking down a page into smaller components? So I want to use this first inventory list page as example, right? We see that we have the search box here, right? This search box here, it helps us to find the inventories that we want to see, right? Helps us to filter the inventory list. This is a perfect example for a reusable component. So basically we need to create a reusable component and maybe call it search inventory, right? And then we have this part of the screen. This represents a list of inventories, right? So again, this is another component. But even within this component, which we can call it the inventory list component, each inventory list item can again be another component. Because of that, we can have this added functionality created within the inventory list item component. As you can see that all of these functionalities are embedded in each individual subcomponents, and that way we can separate all of the states handlings, the events handlings inside each subcomponents, individual subcomponents, so that when we look at each component, each one is self-contained and much cleaner, comparing with putting all of the functionalities into one page component, right? So in this course, we are going to break down things as much as possible. Because of that, we are also going to talk about how to communicate between the components. Because the fact that when we break down a page into multiple components, we will need to have the ability to communicate between the components, like passing parameters or providing a callback, which I'm going to cover in later videos. In this video, we are going to create this search inventory component. In the future, we're going to extend this search inventory component. In this video, we are just going to make a text box and a view button so that when we click on the view button, the component will return the search condition, right? For example, if I say gas, and then when I click on the view button, the search term here is returned back to the parent component, which is the page component, so that the parent component can then use that search term to do the next step. So let's start coding that component. First of all, I'm going to create a folder under the web applications project, and I'm going to call it controls. So we have pages and controls, right? So you can name it components if you want, but I'm naming it controls. This is a terminology that I like to use. And the controls folder will contain all of the reusable components, right? And our first reusable component is the search inventory component. Again, we're going to select the Razor component right here, right? And I am going to call it search inventory component. And because it is a reusable component, so it's not going to have a title here. And it does not need a page directive because we do not need to navigate to this component. We are going to put this component onto a page, and then we can use navigation to navigate to that page. Once the page is displayed, this component will be immediately initialized and displayed as well. So that's why we don't need the add page directive. Now, I'm going to start coding the look and feel first. And if we look at the www root, this is where we keep our static resource, right? Static assets. And we are having Bootstrap as part of the Blazor application template, right? So we can use all of the classes that comes with Bootstrap. So we know that for a group of controls, right, we can use input group. And we are going to have a text box and a button. And for a text box, we're going to use the HTML element input. And of course, it's going to be text, right? It's text type. And we're going to use some Bootstrap class. It's going to be form control, right? If there's nothing here, I want to display a message. That's why I need a placeholder. And I'm going to say type inventory name here to search, right? So this is basically an instruction to the user so that the user know what to do. Okay, so I have the input control first, and now I'm going to need a button here, right? It's going to be a button, and the class is, I want to have that, the green button look and feel, right? And I'm going to call it view, or maybe let's call it search, okay? All right, so with this, I'm going to put it onto our inventory list page. The way to do that is very simple. We go to the page component and we just put it in a proper place. I'm adding a line break so that everything will look better, not too close to each other. And now I just start typing as I'm typing a HTML element, right? So I'm gonna say search inventory component, and you can see that the namespace is added. So in order to get rid of the namespace, what we can do is we can go to the imports file, and this is the place that we can put all of our namespaces for this Blazor application at least. So once we import namespace here, all of the components in this application, right, in the Blazor application, will know that the namespace is already imported. So now if I go back, I don't need to have the namespace anymore, and it will recognize it. See, the red squiggly line is gone. And if I run the application now, let's see what happens. Okay, going to the inventory, and now we can see this. But the button kind of looks pretty weird, right? In order to group this text box with the button and also make it look good, we are going to add some other classes here, which we are going to call input group text. So with this, I'm going to click on the hot reload button. Going back to here, you can see that the text box and the button is connected, and we're seeing this rounded corner on the right hand side, and there's no rounded corner on the left hand side. So this is what I want in terms of look and feel. Now let's continue the coding. What I want to do now is basically when we click on the search button here, we will need to get the user input from the input box and then return that back to the parent component, which is the inventory list component. How do we do that? First of all, we will need to collect the input from the input box, right? In the past, if you do that with JavaScript, you will need to hook up an event handler in the button, and then you will need to get the input element and then get the value of the input element. So that's a manual process. In single page application frameworks, whether it's Blazor or any other single page application frameworks, there is this concept of data binding. Here in this video, we are going to use two-way data binding to retrieve the data directly. For that, we will need a variable to bind with the input control here, right? The input element. So we're going to say private, and then it's going to be a string, right? And what is the name of the variable? We can name it after inventory name to search, because this is done at 6, so I'm going to initialize it with empty string here. So this will be bound to this, and the way to do that is to come over here and say that @ bind value, and then we can just put this inventory name to search here. Now whenever the user input anything in the input box, the value will automatically be stored in this variable, right? In order to see what's in there, we can add another thing here, right? So add a line break, and then we can just put inventory name to search. So we put it here in order to display it. And then I'll explain to you the different types of data binding. Okay, so I'm gonna click on this hot reload button, but it complains that, well, I gotta do the rebuild. And then we go back to here. Now, if I type ABC, nothing's happening. But it's as soon as I tap out or click out, so let me click out, you can see that the variable value is displayed right here, right? And if I add something and click out or tap out, you can see that the value is again reflected. If I delete some letters, still when I click out, it's reflected. So here we're seeing two types of data binding, right? Let's go back to our code. The input control, first of all, is bound to this variable, and this is whenever we have the value here, it's going to be displayed inside the input box, and whenever user make any changes, this variable is also going to store the new value. So this is two-way data binding, right? It goes back and forth to the input box and back to the variable. Now here, when we display the value, this is a one-way data binding that's also called string interpolation. So we are having this variable and the value is displayed one way to the front end. So this is one-way data binding. Now we don't need this variable to be displayed here. I'm just going to delete everything here. The next step is that when we click on this button, we will need to pass the user input out to the parent control. And to do that, we will need to create a special parameter that is called event callback, right? So I'm going to create a property. The type of the property is event callback. And because we need to pass back the value, we will specify the value type here. And then here we can say on search inventory. And now what we can do is we can react to the button's click event. By saying @ on click, and then we can say on search, and then we can add a method here. We can say on search. When we click on this button, this on search event handler will be triggered, and when it is triggered, what we need to do is we just need to grab this information and call this event callback. So we can do like this, on search inventory, and then invoke async. Here we just need to specify what we want to pass back. Because this has a two-way data binding, so this inventory name to search variable will always have the newest value from the input. So I can just call this invoke async to pass this information back to the parent control. Now this event callback is different from action delegate. If this is a delegate, you will have to test whether it is null or not, right? Only when it is not null are you able to call this. But because event callback is not a delegate, so you can directly invoke this event callback without testing whether it's null or not. So now when the search button is clicked, this event handler is triggered. And then we're triggering this event callback to pass the search term back to the parent control. Now let's go back to our parent control here in the inventory list, and let's see whether we can find that event callback. I press the space bar, expecting to see everything that is exposed from this control, but I can't find any. Why is that? Because when we go back to the control, this property is not exposed yet. So in order to expose this as a parameter for the component, we'll need to annotate it with parameter attribute. Now when we come over here and pressing on spacebar, I can see the first one is on search inventory. So I can just take this as an event, and I can say on inventory search, and then here I'm just going to create this on inventory search event handler. Here we'll need to provide a parameter to receive the search term. So I'm going to give a parameter and call it search term. So for testing purpose, I'm going to create a variable in order to receive the search term, right? And I'm going to call this, I'm going to assign the search term to this search term inside the inventory list component. In order to make sure that we actually received the search term from the search inventory component, I'm going to say search term is, and search term. Search term is search term. And we're going to initialize this with empty string. That's it. And we're going to click on how reload and going back here. All right, so we already see search term here. After I typed letters and click on the search button, I can see the search term is displayed here, right? If I delete everything and click on search button, I can see that everything is cleared. And if I type something else, click on the search button, again, I can see this. So our event handler here is successfully triggered, and then the invocation of the event callback is also triggered, and also it also proves that event handler that handles the event callback is also working, right? And then it also proves that our one-way data binding is working too. In this video, we are going to create the inventory list component, which is the component that is below the search inventory component. So when we type something and then click on the search button, we expect the inventories to be displayed right here below the search inventory component. That's what we are going to do in this video. So first of all, we are going to the controls folder, and then we are going to create another reusable component. And I'm going to call it inventory list component. And because it's a reusable component, so we are not going to have a title. Here, we will first of all need to have a variable that is used to store the list of inventories. So here's inventory. I'm just going to call it list of inventories. If I do this, it's going to warn me because this is done at 6. See this? So I'm going to just initialize it with a empty list. Now, I know I haven't populated yet, but once I have it, then I can render the UI elements for the list of inventories. So before I actually load anything into this variable, I'm just going to create the UI element now. So here I can do a table, right? And we can use the table class, CSS class for from Bootstrap, and then we're going to create a table header. We are going to have a few columns, right? We are going to have to see the name of the inventory. We want to see the quantity of the inventory, and we want to see the price of the inventory. And you know, at the last column, we want to have a edit button, although we're not going to work on the edit button, but we want to make space for it. That's why we have this empty column here. We need to construct the T body, and here, this is the place we are going to use this variable. We are going to loop through with the add for each sign. So now we're writing C# with this razor syntax, right? And we can just write C# per normal. So inventory in the list of inventories. Now I can choose to write everything in here, like tr, and then td inventory dot inventory name. Remember, once we started writing the HTML elements, we will have to use the @ sign because the HTML element breaks the flow of C#, right? So I have to do an @ sign here, and then quantity, we are going to say @ sign again, and quantity. And this one, the next one will be the price. And we are going to format the price to a currency format. And then the last one would be the button, right? And the button is going to be a button, and we are going to use Bootstrap light button, and I'm going to format it like this. So we are keeping it like this, but later we will refactor the code and move this out of here to put it into a inventory list item component, right? I want to keep it here so that you can see the problem with having everything together. Now I can start putting this inventory list component in the inventory list page, but you will see nothing except the header of this HTML table. Therefore, we will need to be able to populate this list of inventories. How do we do that? We will need to have a search term that is passed into the inventory list component. Let's go to the inventory list and actually start putting it right here. Let's just put the inventory list component right here. All right, so we have the inventory list component, but the search term that is right over here needs to be passed into the inventory list component, right? So that the inventory list component knows the search term, and then it can load the list of inventories. So how do we pass that information into the inventory list component? It is through something that is called parameters, right? So in Blazor, the parameters is just a property. So let's go to inventory list and start creating the property. The type of that property is going to be the type that you want to pass in. In this case, it's the search term, so it has to be a string. And let's just call it search term. And now you won't be able to see that as a property over inside this, right? So if we type space, you can't see that search term. So in order to actually see it, we will need to annotate it with parameter attribute. And again, we want to initialize it with empty so that it's never null. Then we go to inventory list component in the inventory list page. Then we can specify the search term. The search term will be the search term in here, but we will have to use @ sign, otherwise it would consider this as just a string, right? It's just the search term string. It wouldn't be a variable. So we can use the @ sign here to specify that this search term is a variable. Then we can go back to our inventory list component, and over here we can override a method that is called onParameters set. So this onParameters set method is a lifecycle event of the component. It is triggered whenever the parameter is changed, or when the component is just loaded and the parameter is set for the first time. Now, when this is called, we know that the search term is populated with something. It could be populated with empty. In the case that the inventory list is just initialized, everything is empty. But when it is empty, we return everything. So now is the time we need to use the use case. And we have actually done that in the past when we put it in the indexed page, right? So we will need to dependency inject this use case into our inventory list component, right? So we can go to the top and then we can say inject this use case, and use case name is this. And then we can use this use case name to call the execute method. Well, this is a async method. Therefore, we are going to, instead of use onParameter set, we can use the onParameter set async. So I'm going to override it again. We can see that there is this onParameter set async method. So I'm going to delete this one and use the async version, right? So we can go over here and we can call the async, execute async, and we can pass in the search term like this. And we are going to say list of inventories equals await, right? In order to await it, we should also make this a async method. And now it's just complaining that this has to be a list, right? So we can just say to list, and that's it. Again, this onParameter set is only triggered when the search term comes into this component. Once this is populated, the UI here will be re-rendered. Of course, it's only the part that is different will be re-rendered. This is something you need to remember, that whenever this method is triggered, part of the UI elements here will be re-rendered depending on which part is changed, right? Depending on which variable is modified. Let's go to our inventory list component here and double check that we have everything, right? So we have the search inventory component, which triggers this on inventory search. Once the event callback event handler is triggered, the front end is re-rendered. And when this is re-rendered, the information here, the search term, will be passed into the inventory list component. And then the inventory list component onParameter set method will be triggered. And therefore, this is reloaded and the front end is re-rendered, this part. Okay, so let's give it a test. All right, so we have all of the inventories populated by default because at the beginning, we are passing in an empty search term, and that triggers the onParameter set, right? But if we want to filter, for example, we want to find the body, then we can click on the search button, then it filters. And if we want to see everything again, we just delete it and click on the search button again. And if we put something that doesn't actually exist, it will show everything empty. This is what I want to show you in this video. So we have completed this inventory list item component, but we have one problem, which is the null check. So let's see that we have this inventories parameter because we have enabled a nullable reference type, which actually we should call it non-nullable, right? Because this is not null, but we cannot trust this. So there's a possibility that this can be null, although we have initialized it, right? Because here from the parent component, where we use this inventory list item component, we're using this use case, which actually can return a null value. Although you can see that from the signature of this, let's go to the definition. The interface definition here, we didn't say that it's nullable, right? We didn't give it a question mark. When we call this use case, this actually can be null. And when that happens, when we loop through this inventories, it's going to give us some exceptions. So therefore, we will have to check. Like I said before, enabling the nullable reference type does not actually change our coding behavior. We should check variables to see whether it's null or not whenever needed, just like before. Okay, so here, what we need to do is to make sure that it's not null, right? So we're going to say if inventories is not null, and we can also say that and inventories.count is greater than 0, then we are going to render the items. So we can copy and paste this into it, and we can format it properly. We don't need the @ sign here because the @ sign is already right before the if statement, right? We don't have anything in between that breaks the flow of C#. Therefore, we don't need another @ sign before the for each statement. So with this, it fixes our potential problems. In this video, we are going to refactor the inventory list component because we're having this list item here. This can be extracted out to a separate component. Why we want to do that? Because later we are going to have the edit functionality here, right? And you may want to add the delete functionality if you want. If we still put them in the same component, you will see more and more code in the component, which makes maintainability worse. So imagine if we didn't even create this inventory list component, we just put everything inside the inventory list page. Then you will have a HTML table, you will have the edit functionality here. So that really makes the implementation as well as the later maintenance not so easy to do. That's why we want to break the page into different components, and we look at each component. If we find something that can be encapsulated in its own component, we want to do that. Particularly, we're doing this because all of these components are stateful components. They each have their own life cycles, lifecycle events, and if we want to control all of them in the same file, it's going to be a mess. Let's create a inventory list item component. Inventory list item component. And going back to here, and what we are going to do is we're going to extract this out and put it inside the inventory list item component. Of course, we don't have this list of inventories. We can pass that from the parent component to the child component by going through a parameter. And remember, a parameter is just a property. So if you're familiar with C#, this is very easy to understand. Here, the parameters type would be just a list of inventory, right? And then we'll have inventories. It seems to be a better name than list inventories. And then we can loop through this. Again, we want to initialize it so it is never null. And let's go back to the inventory list component. And here we can just put our inventory list item component right over here. We don't have the property that just because we didn't put the parameter here. So we need to annotate it with parameter attribute. Going back to the parent component, we can see the inventories parameter here. We can provide our list inventories right in here. Now here we don't need the @ sign. That's because the list of inventories is not a string, right? So when the parameter is a string, then C# doesn't understand whether you're providing just a hard-coded string or it's a variable. So that's why you need it to put a @ sign here. but because this is not a string, so it's not confusing to the compiler. That's why we can just do this without the $. Now we have extracted this out, and let's give it a test to see whether it still works or not. All right, going back. Okay, looks like everything is still working, and that's what we want to do in this video. Starting from this video, we are going to work on adding inventory. Okay, so basically on this inventory list page, we will need to have a add button here so that we can click on that button and go to another page where we can input a inventory name, the quantity, and the price. And then on that page, we can click on the save button. The inventory needs to be saved in the data store, and then we should navigate back to this inventory list page where we can see the newly added inventory. So in this video, we are going to start implementing the use case, because remember, we are doing use case driven. So let's go to our code, and then we are going to go to our use case layer and start creating the use case. So we're going to call it add inventory use case. We are going to have the execute method. Again, we are going to use async. And then we're going to call it execute async. To add inventory, of course, we need the front end to pass inventory back to the use case, right? To the use case layer. So we are going to have the inventory passed in, and it doesn't know where to get the inventory. So we need to do a control dot to import the namespace and then the inventory parameter here. Now we need the inventory repository to do this. And for that, we are going to do a dependency injection from the constructor. So this is going to be inventory repository, and we're going to import the namespace and control dot to initialize it as well. Now we have this inventory repository where we can have a add inventory async method to pass this inventory in. So this is going to be a pass through here. Now we're having this squiggly line. That's because it's not in the plugin interface yet. So we can do a control dot, and then we can just hit enter to generate it in the inventory repository plugin interface. And that fixes our problem. Next video, we're going to implement the repository. In this video, we are going to implement the inventory repository. Right? So we can go over here. We can see the red squiggly line here. I'm going to do a control dot to implement the interface, and the add inventory async method is generated. Here, we can simply add this inventory into the inventory list. But before we do that, we need to make sure that the inventory is not redundant, right? Like a duplicate inventory. Right? How do we tell whether we have a duplicate inventory? If we're trying to insert or add a new inventory that has the same name as existing inventory, then that inventory is a duplicate inventory, right? So we need to prevent that case from happening. So first of all, we need to do that check. So how do we do that? We can say that if underscore inventory dot any and x goes to x dot inventory name dot equals inventory dot inventory name, and string comparison is set to ignore case. So if this is the case, that means that we have existing inventory that has the same name. So in this case, we are simply going to just return without doing anything, right? Without inserting. Otherwise, we're going to add inventory into the list. We can do that just like so. And then at the end, we can say completed task. So there's a problem here. This inventory that comes in doesn't actually have an ID. So in order to cover that case, we need to find the maximum ID from the inventory. How do we do that? We can use max, and then we can say x dot inventory ID, right? So this will give us the maximum ID, right? And then we can set the inventory objects inventory ID to the maximum ID plus 1, right? So at this moment, the inventory has a proper inventory ID, then we can add that to the inventory list. And then this method is completed. Now we can go to our add inventory use case and we can extract the interface, right? And now we can dependency inject this inventory use case, which is created right over here. We will need to move this into the interfaces folder. And then we need to go to our program.cs file to do the dependency injection. And again, here, it's a use case, right? It's not a database. So we will want to use the transient method. So this is add inventory use case and add inventory use case implementation. So with this, in the next video, we're going to go ahead to create the front end, and then later we can use the use case to complete the functionality. In this video, we are going to create the front end of adding an inventory. So let's first of all go to the inventory list page, which is under the inventories folder, inventory list page. And we need to add a button so that we can navigate to the add inventory page, because we are going to create a page component for adding inventory. So here I'm going to add a line break, and then I'm going to have a button. And this, of course, this button is going to be a button. And the class is going to be bootstrap primary button. And when this button is clicked, okay, so let me format the button. And when this button is clicked on, I'm going to call the add inventory method, which is a method that I'm going to create. And here I'm going to call it add inventory. Okay, so we don't have this method yet. So let's create this method. This is going to be a private method. And in here, the only thing we need to do is we need to navigate to the add inventory page. For that, we will need to dependency inject something that is provided by Blazor, which is called Navigation Manager. And we can just call it Navigation Manager. And when we go down to the add inventory method, we can call Navigation Manager dot navigate to add inventory. This is going to be the path of our page component. We are ready to create the page component. So we are going to call it add inventory. And in here, because this is a page component, so we can have a title. And the path is add inventory. Now we can test our navigation with the navigation manager. All right, so we are here on our inventory list page. And when we click on the add inventory, it goes to the add inventory page component. In this video, we are going to use the edit form built-in component to collect user input for adding a new inventory. And then we are going to dependency inject the add inventory use case to complete the adding inventory functionality. Here, I'm gonna add a line break. And in order to collect the information, right? So this is going to be a form. Usually in HTML, we're going to have a form like this. But in Blazor, there's a special thing that is called edit form. In this edit form, we can collect information. We are going to collect information for an inventory, right? So first of all, we are going to create a private variable that is called inventory. We are going to initialize it. Then we can go up and create this edit form. This edit form will be connected to the inventory variable here. And now inside the edit form, we are going to use Bootstrap class to create the fields for users to enter the information for the inventories, like inventory name, quantity, and price, right? And we're going to have a form group. And we're going to have a label. and this is for collecting the name of the inventory. Right, I'm going to call it inventory name. And then here we're not going to just use a regular HTML input because again Blazor provided a whole bunch of different views, and here because we're collecting the inventory name, so we're going to use the input text, and the ID is going to be name so that it's connected to the label, right? And we are going to bind this to our inventory name, right? So this is again a type of data binding, and the class will be form control. Right? This data binding will make sure that the inventory name will be bound together to the inventory name variable inside this inventory variable. So similarly, we are going to have another group, so we can copy this. So this is for the quantity field, and of course we can't use the input text. We're going to use the input number, and here we can call it quantity, and we're going to bind it to quantity, and this name has to be added to quantity so that this for field is corresponding to the ID, right? So quantity corresponds to quantity. Again, we are going to have another group of field, or actually another field, and we're gonna call this one price, right? So this is for collecting the price information. This ID has to be updated to price, and this is connected to the price field. Okay, so that's pretty good, but when the user is ready to save the information, we'll need a button, and that button has to be also inside the edit form. So we're gonna have a button, and here it's not going to be a button, it's going to be a submit button, right? And the class, we're gonna make it the primary button, and we're gonna call it save. So we are not going to handle a click event for this button, because when the submit button is clicked on, the edit form will automatically collect the information. But still we will need to specify what's going to happen after the form collects the information, right? So let's go to the edit form and see what kind of attribute or property it has. See, it has a event handler here, and this is called onValidSubmit, right? So only when the information inside the form is valid is this onValidSubmit method is triggered. So we can call this save inventory. Here we need to create this method, and let's use void for now until we use dependency injection to inject the add inventory use case. Right now, because this is called onValidSubmit, so that means there has to be a kind of validation. So how do we deal with the validation here? Right. So the simplest validation is done through data annotation. So now we can go to our core business in inventory. Here we can annotate our field so that we can do some very simple validation. For example, the inventory name has to be required, right? And then I'm going to do a control dot and import the data annotations namespace, right? So inventory is required. And what about quantity? So quantity would be a range. So we can control it to make it greater than 0. And the maximum is just going to be a maximum integer value. That should be enough. And we can provide some sort of message, and we can say quantity must be greater or equal to 0. And we can use the same validation for pricing. Okay, so the price has to be greater or equal to 0. all of these validations will be reflected within the edit form. But when the error message is triggered, how do we display it? So Blazor made it very simple. We can use the validator, the data annotations validator component. And to display the error message, we can have the validation summary component here. So this means that we are going to use the data annotation validation from the inventory class. And the error messages will be displayed on the top. So let's set a breakpoint here and give it a try with debug. Okay, let's go to inventories page and we see this add inventory button. When we click on it, we're navigated to the add inventory page component. And if I click on save button, you can see that the breakpoint is not triggered, right? Because this save inventory method is only triggered when the inventory object is valid. So right now it's not valid because we haven't provided the inventory name yet. So if I provide inventory name, but if this price is a negative value, then it's going to complain that the quantity must be greater than 0. But if I provide a correct quantity, but if the pricing is wrong, it's also going to complain, right? Only when everything is correct, then the input box becomes green and the summary of the error messages will be gone. That's good enough for us. So here is the place where we want to inject our use case. So we can come to the top and use the inject directive to inject the I add inventory use case. And I'm going to call it add inventory use case. Right? And here we are going to call the execute method and we're going to provide inventory in here. So this variable is the variable in the component. But because this is a async method, I'm going to make this a async method as well. Okay, and I'm going to await it right over here. Now, once the save inventory is completed, what we need to do is we need to navigate back to the inventory list component. So again, we will need to inject navigation manager. So we're going to use the navigation manager down here to navigate back to the inventories page. All right, so let's see whether it's working or not. Inventories, and we are going to add some inventories for a car. Okay, so if we are building a car, we're gonna have like car engine, right? And let's say we already have 10 and the price is, let's say 1,500. And if I click on save, I should be back to the inventory list. Now I'm back to the inventory list. I can see my car engine here, right? And if we need a car body, and let's call it car body. And if the quantity, let's give it again 10 car body and the pricing, let's say 500. I don't know how it works, but let's say 500. Now let's try to add bike seat, right? Because it's not supposed to be added because bike seat already exists. We are back to the inventory list, but it wasn't added, right? So if you want, you can do a validation on that, but later we're going to do a lot of pricing custom validations. So here I'm going to skip providing the custom validation and provide that error message. And last but not least, we want to add a cancel button here so that the user can cancel and go back to the inventory list component if he doesn't want to add any inventory. So I'm going to just put a button here, and here it's not going to the submit button, right? Because submit button will trigger information submit. It's just going to be a regular button. And let's also make it primary. and let's call it cancel. And here, of course, we'll need to handle the on-click event, and let's just call it cancel. And let's go to bottom and create a cancel method. And we are going to use the navigation manager, just the same command here, and that's it. Now, among the inventory list, clicking on the Add Inventory button, and let's test the Cancel button. Click on the Cancel button, coming back to the inventory list component. In this section, we are going to work on the Edit Inventory functionalities. So basically what we want to do is when we click on the Edit button, it should take us to this particular inventory and allow the user to make changes to the inventory and then update the inventory. After updating the inventory, the system should bring us back to the inventory list, just like adding the inventory. So in this video, we're going to start implementing the use case. Before we do that, I just noticed that I forgot to create a subdirectory here. So under the controls, I should have a new folder that is called Inventories. And then I'm going to move all of these to enter the inventory. And then what we need to do is we need to go to the imports Blazor here and import a namespace .inventory. After that, let's do a rebuild and then run it again. All right, everything still works. So now let's work on adding the use case. We have already added 2 use cases in the past. So I think you know all of the steps of adding the inventory. So try to do the added inventory use case yourself and see whether you can do it. And then come back and verify to see whether you're doing everything correctly. So here I need a added inventory use case where an inventory item or object needs to be passed into the use case. And then we can use that new inventory to update the corresponding inventory in the. For that, I'm going to create a class and I'm going to call it added inventory use case. And this is going to be a public, and as usual, we are going to create a async method for executing the use case, and the inventory needs to be passed in. So control dot import namespace. Now here, I'm going to use the inventory repository. That's why we need to do a dependency injection here. Import namespace again. And control dot initialize. Here we are going to use the inventory repository, and let's call it update inventory async, and passing in the inventory parameter here. So here I'm going to use a wait because the update inventory async will be a asynchronous method, right? Of course, it's not implemented yet. What we can do is we can go over here and create the signature first. Now, we don't have any warnings here, right? And if we build it, it should work. This purple squiggly line, it just means that we need to do a rebuild. Otherwise, the application, because the application is already running, like this right here, right? It's already running. So it sees that there's some changes that cannot be automatically hot reloaded into the existing application. So it needs a build. So I'm doing a build. And of course, it complains about this, but we're not going to worry about that in this video. All right, so we have the inventory repository already dependency injected into the Blazor application. Now let's extract the interface of this use case. And as per usual, I'm going to drag this into the interfaces folder, and then coming back to the program.cs to do the dependency injection. And again, this is going to be a transient registration because it's a use case. So this is going to be the update inventory use case. And then control dot. So for some reason, this is, because it's not called update, it's called edit. Cool. So we're going to have this edit inventory use case concrete implementation. Now this registration into the service collection is done. In the next video, we are going to implement the repository method. Alright, so in this video, we are going to continue to implement the inventory method that corresponds to the plugin interface, which is this update inventory async method. So let's go to the inventory repository, which is the in-memory plugin. And then I'm going to do control dot to implement the interface. Now scrolling down, I should see the interface right here that is automatically generated. Here, I have this inventory and I need to look for an inventory that is within the collection and has the same ID, right? So I'm going to say inv equals underscore inventory, and then first or default, where the inventory ID equals inventory dot inventory ID. And if inventory is not now, meaning we found it, then we're gonna carry on with the logic. Well, the logic is pretty simple. We are going to just update everything, right? Update the name, gonna update the price. You can use AutoMapper because we don't really have a lot of properties here, so I'm not using AutoMapper. And now we need to return task.completed task. Remember, this is just a in-memory representation of our data store. Therefore, we're simulating the asynchronous calls. Although asynchronous call in this case is not really necessary because everything is in the memory, everything will go fast. But we're using asynchronous method, and all of the method had the signatures of async, so that in the future when we move to NET Framework Core or some other data stores, we will be able to use async, right? Because async has a better performance. Okay, so now we don't have the compilation problems, but there's still another problem, which is if we have an inventory that is updated to the same name as the existing inventory, right? For example, if you update the first inventory and you update the name so that the name of the first inventory is the same as the name of the second inventory, for example, then we shouldn't allow this case to happen, right? Because we don't allow two different inventories to have the same name. And for that, we're just going to add a condition here. We're going to say if underscore inventories dot any. First of all, we need to add a condition that the inventory ID is not the same as the one that is passed in, right? And then we're going to add a second condition, which is the name equals inventory dot inventory name, and the comparison setting is ignore case. Then in this case, we are going to just return task.complete task. So let's examine the conditions. We are basically just saying that if the inventory is a different inventory but has the same name as the passing inventory, that means we're trying to update this inventory to have the same name as a different inventory, right? So this is the scenario that we want to prevent. That's why we're returning from here. So at this point, we can inject the use case into our index page to do a quick testing. And if you have test cases project that is created with XUnit, for example, you can do a test against every use case that you created without considering the user interface, right? So that would be the ideal scenario, but in this course, creating test cases is not in scope. So we're going to do a quick test with the index page to see whether the use case works or not. Because we already did the dependency injection in the program.cs, we just need to inject the use case over here. So it's the added inventory use case. And we're going to call it added inventory use case. And then we can come down here and we are going to first of all create a new inventory object because we don't want to retrieve the in-memory copy and then update it manually and then send it to the update method. That will fail our test case because the in-memory object will be updated already, right? So to make it the same as the actual scenario, we will need to create our object just like this. We can actually copy the first one, right? And then we can put it over here. But we want to change that to 101. And then we can use the added inventory use case and pass in the inventory object we just created and use the await keyword. Now we can actually call this twice just to make sure that we actually update it, right? And then we can set a breakpoint here to make sure the update works. All right, so let's check the inventory. We can remove this search condition so that we can retrieve all of the inventories. And same here, let's remove the search condition. And now we can run debug and see whether everything works. Okay, so let's check. Our first one is bike seat and quantity is 10. Right? And we created this new inventory, which is used to simulate the updated inventory, right? And running after this, and let's also retrieve everything again. And now I expect the first inventory is updated, right? You can see that the first inventory updated. So the first test case is successful. The second test case that I want to do is I want to make this bike body and quantity 99. Pay attention that the inventory ID is still 1, which means I'm trying to simulate the case that I'm updating the first inventory and I'm updating the inventory name to bike body, which should fail the update because we're trying to make the first and the second one have the same inventory name, which is not allowed, right? So this shouldn't update anything according to our coding logic. All right. Let's run through this and check the inventories. And the first one is not updated, right? First one is not touched. Of course, second one is not touched either. So our second test case also succeeded. That means our use case works as expected. Now that we have implemented the use case as well as the repository methods, so in this video, we are going to implement the navigation. When we are clicking on the edit button, we will need to navigate from this inventory list page to the edit inventory page. This is similar to when we're clicking on the add inventory button, we navigate to the add inventory page. But there's a difference. Here, when we click on the edit button, we need to pass additional information to the edit inventory page, right? It's a page component. So in this video, let's see how we can do that. So first of all, let's go to the page component where we have our inventory list, right? And this edit button is in the inventory list item component, which is right over here. Now, what we can do is when we navigate to the edit inventory page, we can pass the inventory ID in the URL. Let's handle the onClick event and let's just call it edit inventory. this added inventory, we will need to create a corresponding method which will allow us to pass the inventory ID over to the next page. And just as before, we will need to inject the navigation manager. And here, when we navigate, we can navigate to the edit inventory page component with the inventory ID. And here we can use string interpolation. Okay, so here we will need to pass in the inventory ID. And you would think that we can do parenthesis and inv.inv.id. But you can see that it complains that this is not going to work. In order to call a method with the parameter provided, we have to use an arrow function like this. This just means that when the button is clicked, the arrow function is going to be called, right? And this is the body of the arrow function. And it will be executed when the arrow function is executed. And then the navigation manager will be used to navigate to the edit inventory page. A slightly deeper explanation about why directly using edit inventory with the inventory in it does not work is that the onClick event handler is actually an event callback. So an event callback is a struct which wraps around delegate. So we're supposed to assign delegate. So when we use edit inventory without a parameter, it works like a delegate. But when you attach a parameter, then it's not a delegate anymore. So you can't assign that to the onClick event. That's why we need to use arrow function to provide a delegate. And then we can call the edit inventory method within the arrow function. Now let's create the edit inventory page so that we can navigating to the correct destination. And here we use the page directive to say that our edit inventory path, and we need to receive the inventory ID from here. In order to receive the inventory ID, we will have to create a property for receiving that ID, and we can just call it inv.id. And it has to be a parameter so that Blazor will be able to automatically pass the inv.id from here to here. Now we can specify the type, which is an integer. And for the time being, I'm just going to display the inventory ID here so that you can see that we actually passed it over. So let's give it a try. Alright, so let's click on the first one, which is the bike seat. And we're passing number 1 over. We can see that. Going back, clicking on the second one. Again, we're passing number 2. Clicking on the pedal, it should be number 4. So it's working. Now, before I finish the video, I want to show you that the inv.id corresponds to this inv.id. So the spelling has to be the same, but case doesn't have to be the same. So I can put a lowercase I, it should still work, right? So coming back, I can still pass the parameters over with no problems. But if the spelling is not corresponding to the property name, then it's not going to work. So I'm going to click on this, and you can see that it throws exception. And the exception is, if we look at the developer tool, we can see it complains that edit inventory page component does not have a property matching the name nv.id. So the spelling has to be the same, but case is not sensitive. Now, if I remove this limitation, the type limitation, let's see what happens. Going to inventory, clicking on the edit button. Now I got exception. And let's take a look at the exception again. Now it says that unable to set property inv.id on the page component because the error is unable to cast object type string to integer, right? What it's actually saying is that if you don't provide the type here, like this, it's going to consider the inv ID as a string. And then it tries to convert the string to integer and fails, right? Because if you don't tell it how to convert, it won't convert for you. So that's why we need to provide this type limitation here in order to make it work, right? So once we provide it, then do a how reload, and coming back, well, I guess once there is an exception, the how reload won't work. We'll have to run it again. Okay, now it works because we have added the type limitation here. That's everything I want to show you in this video. And in the next video, we're going to implement the edit inventory page component here. In this video, we're going to implement the edit inventory page component. Right. So we are going to have the edit form here. But before that, we have to be able to load the inventory. How do we load the inventory? Do we have a use case for that? Let's take a look at our use case. We have a add inventory use case. We have an edit inventory use case. And we have a view inventories by name use case. But here we will need to have a use case which takes the inventory ID and then returns the inventory for us, right? So we don't have that. And we will actually need to make that happen first. We'll have to add a, let's call it view inventory by ID use case. Right, so this is kind of corresponds to this view inventories by name use case. This is going to be a public class, and of course here we will have a async method importing the namespace and call it execute async with a parameter that is a inventory ID. Here we will need the inventory repository. So I'm going to do a dependency injection. inventory repository control dot to import the namespace and initialize it like this. And I'm going to call the inventory repository. Currently, if we go to the interface, we can see that we don't have a get inventory by ID method, right? So we will need to have that method. So we just get inventory by ID async, passing in the inventory ID, and this is going to be a async method. So we're doing this way. So let me copy this and go to the interface here, and I'm going to add this method, and this is going to be inventory ID, like so. Alright, so coming back, there's no squiggly lines anymore except this one, which is fine because we already have application running. So just saying that it needs a build. So let's not worry about that and go ahead and go to the inventory repository and go to the top, do a control dot to implement the interface, and then we can scroll down to the place where we need to implement it. So here we will have the inventory here, and then we can do a first and inventory ID equals inventory ID, and here we're gonna make it async, and we're gonna return await task from result, and we have implemented this get inventory by ID method. Going back to the use case, do a control dot to extract the interface. Now we will need to dependency inject this in the program.cs. So same thing, services.add transient, and we add a mapping here into ASP.NET Core. Now let's go to the added inventory page component, and we'll dependency inject this use case here. So when are we going to call this use case? We are going to call this use case when the parameter is passed in. And for that, we're going to override a lifecycle event, which is, I think it complains because I need to do a build just so that it removes all of the errors. And sometimes Blazor is not working until you close. Let's close all of the windows and see whether it knows what I'm doing. So going to the added inventory, now it stops complaining, right? So let's continue. In order to make sure that we already received inventory ID, we're going to override the onParameter set async method. When this method is triggered, we are sure that inventory ID will have a value. That's why here we're going to use the use case, and this is the place we can pass in the inventory ID where we are going to receive the inventory. Right? So we can say this dot inventory equals, here we need to have a await. And in order to remove this green squiggly line, we will need to just create an empty inventory object. Here I forgot to add an async keyword. Now everything's fine except this purple line, which we don't need to worry about. So now we have this inventory object. So we can work on our added form, which we can copy from the add inventory component, copy this whole thing, and just do some modification. So coming back over here and paste it here. And this added form is going to be bound to this variable that we just created. And we don't have a save inventory. Let's have a save inventory method. And we know we're going to call the added inventory use case, which has a asynchronous method. So I'm going to use async right away. Let's just remove this for now, just so that it doesn't complain. And we can go up, and we can see that this squiggly line is gone as well. We're going to keep the data annotation validators. We're going to keep the validation summary right here. Here everything stays the same, and here everything stays the same. And of course for pricing, everything is the same as before. And we have a submit button and we have a cancel button. So cancel button just to cancel out, because if we don't want to edit, we can click on the cancel button to navigate away. So we can have the cancel button implemented here. We're going to use the navigation manager, which we can dependency inject at the top. Navigation manager, navigation manager. And then when we go to the bottom, we can say navigate to. So we're going to navigate back to the inventories. So the inventory list. So the path is inventories. Now here we are going to use the added inventory use case. So again, we need to go to the top and do another dependency injection, which is I added inventory use case. And then coming down and put this over here. So it has a execute async method, and here this is where we pass in the inventory, and we already have this inventory, which is this one, because remember this inventory variable is bound to the edit form, and this save inventory method is only triggered when the inventory is valid. So when this method is called, we know that we already have a valid inventory object inside this variable. Okay, so we can call this method and there shouldn't be any problems. Of course, here I will need to use the async keyword, and if this is successful, then I can do a navigation. I can just navigate back to the inventories like so. So now let's do a build, and I'm going to actually close the window, and I'm going to let's do a rebuild, make sure everything is built properly. Okay, and then let's do a start without debugging, and let's go to the inventories page and click on the first one. So we're editing bike. Let's imagine the price has increased to 2.5. Okay, so let's put 2.5 here. Let's try the cancel button first, going back, which is exactly what we want. But what we notice is that the price is already updated. The reason why that is happening is because in here, when we retrieve that inventory, this is a reference to the one that is in the memory. It's not a copy, it's a reference. This is going to be a problem for us. So in order to solve this problem, let's go to the get inventory by ID here. Let's change this so that we have inventory, and then we are going to create a new inventory, which has the same information as the old one. You can use AutoMapper if you want, so I'm gonna cut this. And then return the new inventory. So this should solve the problem. Let's do a rebuild. And let me close this window and click on the start debugging. And coming over here, and let's try that again. Let's put 0.5 and clicking on the cancel button. Coming back, you see this is still $2. It's not 2.5 yet. All right, so if I do 2.5 and click on save button, now it's 2.5. And that's expected. Now, if we change something else, just to make sure everything also works, updating the quantity, it's also working. Going back, we can see it updates. Now, if I change this to bike seats, for example, the name is updated as well, changing it back to back seat. Now let's test the edge scenario where I'm going to update this bike body to bike seat, and it shouldn't allow me to update it. So coming back, I can see this bike body stays as bike body. That's everything I want to show you in this video.